Hey guys, I'm just going to show you the examples from exercise 8b. So talking about unions and intersects. I'm going into this cold, so hopefully I don't make any mistakes. Anyways, question 1. Consider the given events A and B that involve numbers taken from the first 10 positive integers. So here we have a set A, 1, 2, 3, 4, 5, 6, and we have a set B, 1, 3, 7, 8. So just two random sets that involve some random numbers taken from the first 10 positive integers. So represent the two events A and B in a Venn diagram showing the number of elements belonging to each region. So we'll just quickly sketch up a Venn diagram. It's important to have this border around our Venn diagram, because if there's something that does not exist in A or B, then it will have to exist in this border region. But anyways, we see that we've got 1, 3, 1 and 3 in common, so I might give myself a bit of a bigger intersection here. We've got 1 and 3 in common, so I might just chuck them in like that. We've got 2, 4, 5, 6 belonging just to A, so 2, 4, 5, 6 belonging just to A. We've got 7 and 8 belonging just to B. Alright, so you might think we're done, but we're talking about numbers taken from the first 10 positive integers. So if we consider all the numbers, the first 10 positive integers, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, actually the first 10. So we could either include 0, or we could include 10, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You know, just the first 10, however you want to consider it. We'll say 1 to 10. So we've got 1, we've got 2, we got 3, we got 4, we got 5, we got 6, we got 7, we got 8. There's actually no 9. And there's no 10. Okay? So you could either say 9 and 10 on the outside, or you could have said 0, 0 and 9, perhaps as well. Okay? It does say in this question, showing the number of elements belonging to each region, so you probably could have gotten away with saying, well, there's 4 elements in this region over here, so I'm just going to put 4 there. There's 2 elements in this region here, I'll put 2. There's 2 elements over here, 2 elements down here. 4 plus 2 is 6, plus 2 plus 2, that's 10. So a total of 10 numbers sort of spread out between these sets as visualized here. So now we're just representing how many numbers are in each of these regions. But anyways, that's the Venn diagram done. Now we need to list the following sets. Okay, so A intersect B. Well, here I'm actually going to go back to what I had previously, because this is going to help me a bit more. So A intersect B, that means A and B. So this is A, excuse me, I forgot to label these sets. This is A, this is B. We see that the intersection of A and B contains two numbers, 1 and 3. So the list the following set, A intersect B. I would say A intersect B, squiggly bracket, that's just 1 and 3. So remember, when we list things in maths, we do it by placing our list within these squiggly brackets. Okay, next one, A union B. So this is what is A or B. Oops. So the list of numbers that are A or B was every integer from 0 to 9, except for 0 and 9. Or every other integer except for 0 and 9 is going to exist in either A or B. So our set will be 1, 2, 3, 4, 5, 6, 7, 8. Okay. See, if a number from the first 10 positive integers is randomly selected, find the probability that the following events occur. Okay, so if I pick a number from 1 to 10, what's the chance that it's going to be either 2, 4, 5, 6, 1, or 3? Right, so remember 1 and 3, they're still in set A. So the probability that I select a number in set A, Well, out of the 10 possible numbers, so this was A, this is B, C we'll do over here. Out of the 10 possible numbers, I've got 1, 2, 3, 4, 5, 6. 6 elements in set A. So 6 out of 10 is my probability for selecting a number in set A. We can simplify that, of course, to 3/5. Probabilities, though, is the one topic in maths where you can kind of generally get away sometimes with not simplifying. I would still simplify, though. I would give both, just in case. But generally, when we talk about probability, it's not necessary to simplify because there's information here, right? We're talking about out of 10 possible outcomes. So if I simplify, I kind of lose that. Now I don't know if it's out of 10 outcomes or what. Okay, but anyways, the probability of the event A intersect B occurring. So I should probably give you a bit more, like how we would actually write this out. I would say, well, what's the probability of A? The probability of A is equal to 6 on 10, okay, which is equal to 3/5. I'll just give them both to be safe. Now, if I was talking about the probability of A intersects B, I'd say the probability of A intersects B. Remember, A and B. Well, that's going to be the digits 1 and 3. So that's 2 outcomes out of the possible 10. 2 out of 10. 3. Probability of A union B. What's the probability of A union B? Well, we can see that A union B, remember, that's A or B. So what is A or B? Well, everything within these two sets is going to be either A or B. So only what is outside these sets is what we can consider to not be A union B. So the probability of getting something within those two sets is going to be 8 out of 10. Remember, we can simplify these, but we'll give both answers just to be safe. Alright, last. Are the events A and B mutually exclusive? Why or why not? Well, we see there's an intersection here. So some events that occur in A also occur in B. So they can't be mutually exclusive. No. Because intersect is not an empty set. Oops. Okay. Let's have a look at these other questions. Are they worth doing? Yeah, may as well. Let's just get them all done. So from a class of 30 students, 12 enjoy cricket, 14 enjoy netball, and 6 enjoy both cricket and netball. Illustrate this information in a Venn diagram. So actually, I would really encourage you guys to pause the video and try first, right? And then if you get stuck or if you feel like you got the answer, then you can come and watch the rest of this, check your answer. But anyways, so we are talking about a class of 30, 12 enjoy cricket, so there's going to be 2 sets we're speaking of. We'll call this one C for cricket. We'll call this one N for netball. Can I make this bigger? I can. Nice. C for cricket, N for netball, and let's not forget to box or border this for all those people that like neither cricket or netball. So I might say up the top here, top left, I might say N is equal to 30. Total number inside this Venn diagram is going to be 30, right? And I know 12 enjoy cricket, so I'm not going to put that 12 in here straight away, right? I'm going to say C is equal to 12. Okay, I'm not going to put any information in just yet. And let's say netball, number of people who enjoy netball, that's 14. Okay, so now the information I do have, 6 enjoy both cricket and netball. So I know if they enjoy both cricket and netball, they're in this intersect region here. And, right, they enjoy cricket and netball. There's 6 of those people in here. Okay, so 6 people enjoy both cricket and netball. Well, that accounts for half the people that like cricket, right? There's 12 people that like cricket. 6 of them like cricket and netball. 6 of them exist in this intersect. That means 6 more will only like cricket, right? 6 people like cricket and not netball. 6 people like cricket and netball. All right, now people that like netball but not cricket, that's going to be 14 take 6. It's going to be 8 people here that like netball but not cricket. So that's my, and just to kind of make sure I've accounted for everyone here, we got 6, 12 plus 8. There's 20 people here. So there's a total of 30. That means we've got 10 people that like neither cricket nor netball. So this is our Venn diagram done. State the number of students who enjoy netball only. That's going to be 8. Netball, neither cricket nor netball. That's going to be 10. The probability that a student chosen randomly from class will enjoy netball. So people that enjoy netball is a total of 14 of them. So that will be 14 on a total of 30. So we'll leave that as 14 over 30. Netball only, so that's just these 8 people who only enjoy netball. That would be 8 on 30. And we can simplify that to 4 on 15. But we'll give both answers just to be safe. And find the probability that a student will enjoy both cricket and netball. That's going to be 6 on 30. So I might do that down here. 6 on 30. And we might just say that is 2 on 10 as well if we wanted to simplify.